I wrote something down. I don't know if I'm going to pronounce it properly. Bunaziwa Bine van Gesit? Okay, so that meant good afternoon. Welcome everybody. I see my slides are not showing yet. Is it working? Ah, now they are. Okay, cool. So welcome everybody for joining this presentation. So we're going to talk about QA in the DevOps time period. And I heard the question about the Spotify model. Actually, the bank, ING, there was also someone here from ING. I worked for, look, that you posed the question as well, right? Okay, so ING Netherlands went to the Spotify model. So they changed it around. So I'll touch on that during the presentation. Also, a bit of this is based on what they did at ING Netherlands. So we'll come about that. So we'll start with the definition of testing. We used to have a definition of testing when I started in this world is getting an independent judgment about the quality of the test object. That used to be the definition of testing. Well, that doesn't apply anymore. We're not, giving an independent judgment. We're nowadays more about giving fast feedback. Testers are part of the development process. They're not at the end, so they'll help building a better product. And that's also why I like to say I don't want to use the term QA anymore, quality assurance. I want to use the term QA as quality assistance or quality engineering. Because quality assurance is still more focusing at we're going to ensure at the end that you're not running into problems. It's been a contaminated term actually. So that's why I want to move to new terms used by actually more modern companies, and Atlassian uses quality assistance, for example. The previous speaker, Peter, was from there. Maybe he can also tell you more about it. And quality engineering comes from Spotify and also ING nowadays. So diving back, we saw this earlier as well. Just to give me a small crowd, who already works in DevOps? A couple of hands. Who works in an agile environment? Scrum? Okay, someone still in the waterfall period? That's not a bad thing though, right? It's just the phases where you're in. See someone? Waterfall inside Scrum, that's what you see a lot. So that's what you want to change. We'll actually come back to that point because I see that so often. So I go to a lot of customers and then you'll see this happening. What they do is they do Scrum and then they do waterfall in it. So they do specifications, design, code, test, and then maintain. They try it all to cram it into one sprint, or they cut it off after design phase. That's not really working. So looking back, we're going to focus on testing, but testing has changed. Like the definition, testing is more and more. If you look at the DevOps circle, it's going round and round and round, and we have all the phases coming next to each other. And doing quick deployments, also on Friday. So that means that we need to have a lot of tests, or, as I like to call it, feedback. Because not everything is test, a lot is also feedback. So you get a lot of feedback, and you get feedback on the different phases. So this morning we already touched on the shift left. So the shift left is moving towards the left in your cycle, in your development cycle towards specs. Well, that's also what we do. We get feedback earlier and faster and more. So we can, take mistakes out of it quicker and go faster into the development cycle. So moving from assurance to engineering, quality engineering. What is quality engineering? Well, quality engineering is the maintenance, development, and operation and maintenance of IT systems. So basically everything. That's what we put under quality engineering. Quality engineering goes about everything to ensure our customers the high quality product we want them to experience. And we need to take some steps moving towards quality engineering. So if we look at everybody here, who is actually in the crowd? Do we have testers here? Okay, cool. You're going to become quality engineers. Do we have developers here? Cool. You're staying developers. I'm only focusing on testers. Do we even have, like analysts, people who are someone halfway there? Do we have people designing, like architects? Same one, putting his hand up all the time. Okay, so I'm brushing on testers. Testers becoming quality engineers. That's the first part of the presentation. The second part is, okay, the quality from the start. And this morning, John already talked about how do you do that with BDD. Well, actually, connecting the dots in this presentation, that's what we need to do. That's what we as quality engineers need to do. Automation, automation, automation. It was 3 times on the slide of Peter, or on, sorry, not Peter, of Michiel. Or at the same time here, 3 times automation. Automation is a big important part of our new line of work. We need to automate stuff, so that's an important part. Also exploratory testing. We talked about the bug hunt. We cannot test everything automatically. So we're gonna touch on that, and the grand tour, well, it's the big surprise for the end. So, moving from tester to quality engineer. So what's changing? So this could be your team. This could be your DevOps team. We have dev, we have ops, we have an analyst, we have a tester, maybe different sizes. Well, what we say in DevOps is they all share the responsibility for quality. Looks good, all right? And then this happens. We have someone who is responsible for writing tests, only doing tests. That's gonna inhibit the feeling of quality. Actually, it feels a bit like waterfall. We have someone doing the test. Well, that's one of the parts in that complete cycle. So we don't want that. What we want to do is make that new quality engineer, well, not responsible for quality, because the whole team needs to be responsible for quality, but someone taking the lead, someone being that quality engineer. And I'll go into the values for the quality engineer later on. But the main thing is we're not doing someone for quality up front and someone for quality when we halfly build it. No, we're gonna put someone in that place for the entire circle, and maybe you need 2 for a team or more. But the quality engineer is gonna replace the analyst and the tester. And this is what companies like Spotify did, and also what ING tried to do. Replacing the old tester with a new function that is constantly thinking about making sure we maintain quality. And how to do that, that's the other slides in this presentation. When I started with ING, they got rid of the testers. Testers are waste, right? Get them out of here. That's what they said. That's what one architect said. And what followed was they sent about 200-300 testers away at ING. What happened 2 years after? They came all back. We needed them. Quality was bad. And they needed coaches, they needed trainers, and they needed agile test coaches. That was my position. And they wanted to move to quality assistants. Quality assistants, that's what they did at Atlassian. At Atlassian, they got rid of their testers from an early stage and moved it to quality assistants. Why? They will help you get better quality instead of doing only the tests. So the name change made a difference for them. Also, they didn't test at the end. They actually got rid of a big testing phase at the end after migration, just to make sure that their teams felt the pain of their failures instead of being a safety net. So some definitions of Spotify and Atlassian about this new role. Where Spotify has chapters running over teams with quality engineers. Those engineers will help develop the teams with a quality mindset. So they advocate for quality and they assist engineers. They basically help make high quality products. And the quality assistants at Atlassian, they focus from outside of the team in helping a team optimize the process and educating developers. So if you ask me, what does the new quality engineer have to do or has to have? He needs to be an advocate for quality. Today I saw an advocate for development, an advocate for CI/CD, if I'm correct, Michiel. We have advocates for quality now as well. And he needs to actively coach developers and business. He must make sure that not only the teams understand the importance of quality, but also the part with the requirements needs to be good. Otherwise we'll build the wrong stuff anyway. And we must make sure that testing is part of the development process. We must coordinate the testing efforts outside of our teams. We need someone who stands up and makes sure that we do the tests outside of our team, because they still need to happen. And maintain test reporting and visualization. I don't mean the big test reports like we used to with paper document, but keep those key indicators there to see how good you're doing and if you're improving, and spot the opportunities for test automation and keep improving on that. So that's the first part about the quality engineers. But now we're going to look at what does a quality engineer need to have? How are we going to make sure that it provides quality? And actually, all the presentations before this one were actually all connected to that quality engineer. And the first one was quality from the start. And actually, John talked about BDD. He talked about, doing the conversation, not writing specs, and that's what quality from the start is for. And I'm gonna touch on it a little bit more quickly than he did, but it's important to understand this correctly. So, if you have your basic team, it basically builds software for a lot of people. For the customers, there's some kind of strategy. There are managers, executive. They all have wishes. They all push on the team, or on the product owner in this case. And they all have a different story. So what you need to do is you need to understand that story. If you know what the story is, from all those people and the main vision, you can build a better product. You understand why the product is needed. And that means you need to bridge the gap. You need good user stories. Because if you're getting crap user stories that don't reflect on that story, you're gonna build crap. Crap in is crap out. So you need to understand the story. And if you don't understand the story, you will see different things in this picture than I do. So this is an example. So if I ask you, what do you see? Probably you see sunrise or the sun going down. I see hot air balloons. And even though you might see the temple over here to the right, you see some stuff. But that's basically you're naming the things you can touch. What you don't hear, that this was my holiday picture. And I'm telling you the story now, and then you'll see the picture a little bit different afterwards. Same like going towards to see the river. If you see the first time, turn around, see it again, it's different. Same happens with this picture. So this picture is my holiday in Myanmar. And it was 3 years ago, and it was a bus ride from one side of the country to this place. And it was basically a ride for 8 hours, and I didn't sleep for 1 minute. I was so tired getting out of the bus. This is sunrise. I ended up at the hostel, and about 20 guys were running out. Yeah, we're gonna go on a scooter, and we're gonna go to the temple. We're gonna see the sunrise. And I was so tired. I was like, oh, what the hell? I'm just gonna do it. So I went with them. We went for a 30-minute drive, bumpy roads, sandy roads, on a scooter, ending up at the temple, going inside, crawling through, well, these kind of spaces. I'm pretty big. Crawl down, crawl in, go up to the roof of the temple. You could actually enter a temple, and then you're there on the stage, and then you're waiting. You don't see anything, and 10 minutes later, this picture, like the sun rising, the hot air balloons going up in the air everywhere, and the mist through these temples and through the trees. It was an amazing sight. So if you wouldn't know the story, this picture would have less context. So it's important to know the story. And the same goes if you're building software. This picture doesn't do anything for you, but software does. You're building for a customer. So it's important to know what the story is that the customer or that product owner or those executives have. So do a little test. I mean, I didn't give you any context. What do you see? Oh, really? Is he showing this? Okay, so I guess you're seeing a couple making love. So that's not what I meant. I meant, can you see the dolphins? If you know the context, you know where to look for, you know what to build. So that's with telling the story. Make sure you tell the story and that you show it. Because this love-making couple, if you show it to kids, they will say, hey, I see dolphins. They don't see the couple. So it depends on the context you have and the story you know, what you see. So these techniques were also already touched by John this morning. Impact mapping, user story mapping, two techniques to make sure that story that the business has is clear and you know what they are talking about. So the one to the right, impact mapping, is about how do you know you make impact on your customers? How can you make that explicit? What do you want to reach? If you know what you want to reach, you don't have to build your specs. You can think with your customer, with your product owner, with your executives and your customer, how to reach that. And the same goes for user story mapping. User story mapping is a technique to make sure that that story that person has in mind, that you map that and you make user stories out of it. So this is a technique to make multiple user stories, to slice a big story and a big thing a customer wants to smaller things. So then you get some user stories. And these user stories, well, you don't want big acceptance criteria list specifications, because we learned we want to know what the customer wants. And if we're going to build specs, you're going to get stuff like this. This is from cakeracks.com. It's a really cool site, look it up. And this cake has "I want sprinkles" on it. So I think the person wanted sprinkles on the cake and not the text "I want sprinkles." Or another one, "Best wishes, Sugarne. Underneath that, we will miss you." I don't think you want underneath that on your cake. So these are basic miscommunications. Or this one, "Happy birthday, Calvin." And then in parentheses, green. I think they wanted it in green, not in red, and I don't think they wanted that on the cake. So these are real cakes that have been delivered. If you talk about writing specs down, not knowing the story, this happens. So if you know that story, if you have good user stories, and we already heard BDD, and we already heard TDD, I like to use the term ATDD, acceptance test driven development. You can already write down your specifications in tests, in acceptance tests. And if you have your acceptance test, you can build it. And you can build it up front, so you have a failing acceptance test. On that acceptance test, you can hang a couple of, TDD tests, so unit tests on a lower level, to make sure you get to your goal as quickly as possible. And if you start building it, you go around the circle, the tests fail, you're going to build your code as quickly as possible to make the test pass, and then you're going to refactor. And you want your code still to work, so you still want your test green, otherwise you refactor too much. And after a couple of those tests, you might even pass the acceptance test. So what you want to do is use that acceptance test to drive your development cycle and to build quickly and fast and make good quality products. And to go to those tests and those requirements, use examples. Already said this morning, so I took a couple of slides out to save time. BDD is a good way to make sure that you get your examples. You get feature mapping, you got user story mapping. Those are two of the techniques. Or you have a really good book about it by Gojko Acic about specification by example. What you basically do is you go together with the business, get those examples out of him. What do you really want the software to do? And if you have those examples, write them down and make them into tests. So this is one of the examples of ING. I coached the team at ING, and they did this. And they wanted to do something more for the business. So what they did is, this is a rebuild of a bigger dashboard. They had this dashboard online. And they had their tests for the current feature, or the current features. So those are all the features that are online. And they have for the next sprint, so they're still building stuff. And what they did basically is they run the test every couple of, minutes. And it would set the result. So what allowed this is, this was running on acceptance, so they pushed quite often to acceptance. They did multiple deployments, and they made sure that they did the deployments to production as well. This run on their acceptance environment. So what they did is they run their tests constantly against the features that are available to see if anything breaks. or how far the bottom features are. And they had a coloring code. Green was good, like always. Orange was, okay, one of the underneath tests is broken, but the main functionality seems to be still okay, or it's under construction. And red means that it's totally not passing. So the team was able to run this entire set of tests within 5 minutes, and they did it continuous afterwards, so you would always know what the status was of their development, of their test environment, and how far their development was. So this was quite a nice idea of providing more insight for the business. So that was already a step in automating, and we're now going to really automate the automation part, because automation is important for us as quality engineers. We need to make sure that we automate our tests, because, well, testing takes a lot of time. You can make mistakes, and we need them to be fast, reliable. We need them to be reusable and repeatable, and we must make sure that that works. There's a bug in the slide. So we all know why automation is important. So how to approach it? Well, it's quite simple. Testing pyramid, also shown before by Michiel. It's try to automate as much as possible, as early as possible. So you want to put as much in the unit component part as possible. Because it's faster, the tests are smaller, it's easier to maintain, and one of the approaches is TDD. On your integration, they're faster, they're a bit bigger, they might have some dependencies, but they're still easier to maintain. You want your ATDD tests focused on that point. You might come to a part where that's not possible, but they'll end up in the user interface. You don't want to do a lot on UI level because they're slow. They take minutes instead of seconds. They're big, they have many dependencies, they're flaky, they're high to maintain. So you don't want to do a lot of automation there, only your happy flows. And somehow there's something going wrong with the mirroring, because the slides up here are good, but I see some stuff going up there, so just try to ignore it. So context is key. The 70-20-10 is not a hard rule, but you have some context that might be different, and that means that your pyramid could look a little bit different. So you have your self-built software versus bought software, Java, JavaScript, C++, C#, employee versus client facing. That really could make a difference. And quality goes further than test automation. I mean, the more you automate, the more, the less mistakes you're gonna make. It's also something Michiel touched on, is you want to make sure that you automate as much manual steps as possible, because you can take the mistake out of it. You make sure that you don't make that manual mistake, and you're focused on really the maintenance and the development of new features. So currently I'm doing a project at another big bank. It's a Rabobank from the Netherlands, and basically my function is to help them automate. And it's something that I wanted to touch on because you are all the experts. You're the developers, you're the testers, maybe even operation engineers. You're the experts. And that's also what I try to tell them. So at Rabobank, I have the most easy job of all, or actually it could be really hard, but don't tell them. It's getting that information outside of the people's hats. They know what's good to automate. They know how to automate. They are gonna do it, so I want them to take the lead. The only thing I do is make sure that we get that information out of them, put it on a backlog and on slides, and I'll present it and make sure that they get time for it. So this is one of the slides where we basically divide all the different stuff into tools, and we're making basically a tooling strategy, and we'll convert that into a roadmap, and we'll make sure that the teams, take this constantly within their sprints. Every sprint, they take parts of it and make sure that we keep automating. So if you're still a newbie, you don't have any automation, start with this and, change it along the road, because this is already changing as we speak, because last night I had a call and someone said, well, maybe we shouldn't go for XL deploy. Okay, so you're the expert. What should we choose then? Okay, we should try to do everything with Ansible. Okay, great, let's go for it. And then the roadmap changes, but the more insight they gain, the more it changes. So be flexible and try to use these techniques to give it a boost and get your automation on the way. And now we're going to build a bridge to the bug hunt presentation from Sillard. And also something that Michiel touched on. Because nowadays we try to automate as much tests as possible. At ING someone said, we're going to automate all the tests. We're not going to do manual testing anymore. Okay, that's the most stupid thing I've ever heard, but that's an architect. So he probably doesn't know how it works. Why? Why can't you automate all the tests? I'll show you why. So I want you to count the amount of passes the team in white makes. It's... Wait. Otherwise it doesn't work.
Does the team in white make?
So count the amount of passes the team in white makes. Okay, what's the answer? 13? Okay, that's cool. Did someone else see something else? The dancing bear. Did you know the video already? You as well? Did you know the video? Okay, the people who know the video see the dancing bear. The people who didn't see this video before didn't see the dancing bear. And they're like, what? Is there a dancing bear? Yes, there is. I'll show you.
The answer is 13.
So 13 was good, by the way.
But did you see the moonwalking bear?
Go!
Here he goes, here he goes. So, did everybody see it right now? Otherwise, I'll send I can send the link on Twitter, so you can look it for yourself again. This is the difference between automated tests and the tests you think up front. You know that the team is going to make some passes. You focus on that. You want to know that the number is 13, and you completely miss that there is a bug, or in this case, a moonwalking bear in front of you. So that's why you do exploratory testing, to find those mistakes. And to elaborate a bit more on that, this is the testing synergy. So nowadays in Agile, we are not building big documents. We're not going to think of everything up front. We're going to do the thing we need to write some checks for that, and we're gonna do that. We're gonna automate those checks. But there is a lot we don't know of that product. We want to know more. We want to know if we can deploy on Fridays. We want to know what's missing. So the known knowns we know, but the known unknowns and the unknown unknowns is the part we don't know yet. And how big that part is depends on how much time you invest up front trying to find and write everything down. If you have an important product and you put it live, you want to make sure that you have as much information as possible. So that's why you want to do exploratory testing. That's why you want to explore your software. So what is exploratory testing or exploratory testing or exploratory testing? Well, we saw a different definition. I like the definition of Elizabeth Hendrickson. Basically, it's a style of testing in which you explore your software and you think of the steps you're going to take. So you're going to have your imagination. You're going to get the journey there. And you want to make sure that you get the last feedback from the last testing step to make the next one. So a couple of important things to keep in mind. Do it time-boxed. Use charters. do a debrief in the end, and do it in pairs, because it's so easy to miss stuff if you're not doing it together. And make sure that you're focused. You're not on your phones, you're not on Facebook, just focus for that time box. So, charters, and those charters go into the cycle of exploratory testing. You design a test step, you execute, you try to think of, okay, what could the result be? Because that's an important thing in testing. You learn from that step, you get the feedback, you steer towards your next step, you design the next step, think about the outcome, and you'll execute it again. And you'll do that again and again until you have proven your charter, or you found what you were looking for, and at the end you'll have a debrief. But of course, you can automate this as well. Well, can you automate exploratory testing? Maybe with AI. I'm currently looking into that, but that's going to be a couple of years ago. What can you do now? And already someone told us about canaries and feature toggles. I have 2 examples for you. I'm not going to talk too long, but that's a way of letting our customers do our exploratory testing for us, making them part of it. But you can only do that when the risk is minimum, and you know your customers, and you can monitor and explain that to them. So that's what Facebook did. Facebook did it this year, and they did it the way new customers got the new website first, and old customers got the new website at the latest point. So at some point, I give LinkedIn trainings within my company. We had stuff like this. We had 2 versions. That makes the training so hard to give, because you're showing everything and they all had a different version. So we had the new layout, we had the old layout. It meant a couple of differences. And what they did is they migrated a couple of persons or groups a day, and then it took actually 2 weeks before I went to the new version. So that was quite inconvenient. But that's one of the examples of doing a canary release, and this is by customer selection. The other one is one of a team I work with, the Ideal team in the Netherlands for a banking solution. They wanted to use QR codes for payments, and they got this feature online pretty quick, but they put it on a feature toggle, so only friends and family and only people within the company could test. And they left it there for almost a month, and then went live without any problems. During that period, they found a couple of things. So it was basically, putting it there. There was no rush. No one expected it before a certain date, and then put it live. And again, with feature toggles, don't use too many feature toggles. I was at a team at Rabobank last week, and they had about 40 feature toggles going through each other. So it's one giant mess. So you don't know what's there anymore, which experiments are running. Keep it controlled and make it an experiment. Make sure that you document what you're doing and make sure that it's there. Okay, the grand tour. When we are using software, it's more than functionality. We think about functionality all the time, but it's about way more. It's about the grand total. So if we take an F1 car, for example, an F1 car, I saw a picture earlier today as well. You can have the best engine in it, but if you have the best engine, the Mercedes engine, like in Malaysia this weekend, most powerful one, fastest one, but still, they weren't first. You need to have everything. Everything needs to be good and great. So you need to have a good engine, but you also have to have good electronics. You have to have a good driver. You have to have good tires, a good balance in the car. All those things are important. Same is for software. You need to have performance, resilience, security, usability, accessibility. Also, the components you use need to be of proper quality. They need to be there, and they need to be reachable and good. But also the tools you use. Within ING, we use central build pipeline, and that central build pipeline went down all the time. So that's really horrible when you're in a release or trying to put stuff live, if it doesn't work and you're not able to put it there. So quality engineering, keep the end customer in mind. Make sure that you're helping him and doing everything to make sure that it's working okay for him or her. So I talked about quality engineering and our quality engineers. Quality engineering, we have a couple of key principles. And the key principles already talked on in Agile and the previous presentation. Customer first. Always put your customer first. The whole team is responsible for quality. Don't forget, even if you're a quality engineer, make the entire team responsible for quality. Everybody needs to be responsible. If one person takes responsibility, the whole concept fails. Testing is not only the automated checks, but also exploring. Don't forget that. Do the bug hunts. Bugs are fixed when they're found. We tend to skip stuff because we think, well, we'll fix that later on. We'll come across it again. I still need to refactor. And then it doesn't work or we don't find that problem. Done, our definition of done also means fully tested. Quality should always be before new functionality. If you compromise on quality, you're doomed. Because if you're building on and on bad quality, it's going to get worse and worse, and you're only making your software base bad and even worse. Collaboration, guys, if we don't work together, we're never going to deliver quality. So, I also like movies. I also put a slide in. Dr. Stephen Strange, he asked the question, how do I get from here to there? The same question you might have. You are all experienced people. You all have many years of experience, either testing, either developing, either working in teams, working together. Use that experience. And Scrum even helps you with this. Because Scrum, you have your retrospective, and in your retrospective you can think about things on to improve upon. So that's my challenge to you. Next retrospective, tonight, whenever you're together with the team, think about what can I do to make quality better and to help my team do better. And the answer of Dr. Stephen Strange was study and practice years of it. You have those, so take those with you and take this new information with you about automation to drive quality, quality engineering, quality from the start, the ground tour, and exploration to make sure you do the proper tests. And if you have any questions, you can reach me on Twitter, you can email me, or you can add me on LinkedIn. Thank you for your attention.
Thank you very much, Geoffrey. Questions, please.
Hello.
Hi.
What would be a difference between canary deployment and beta deployment?
Beta deployment.
Yes.
Well, that depends, I think, on the definition within your company. I mean, if you look on the internet, it's been quite a mess. If you look up canary releasing, beta releasing, beta trials, A/B testing, they all have a bit of the same basis, but are used for different types. So A/B testing is mostly used in marketing. And if you mean beta testing with that, then that would be the way to go, I would say, in definition-wise.
Thanks.
You're welcome.
Other questions? Seems it was very, very clear. Thank you very much, Geoffrey, once again. Your big applause to Geoffrey, please.
Thank you. If you have any questions, I'll be around for at least another hour. Thank you.